Welcome to Bite-Size Data Science. At the end of video 38, I mentioned the Keras applications that come with the product. These are pre-trained models for image classification. They were trained using the ImageNet datasets. I found a table that shows some statistics on multiple well-known models. The table gives us some information on the different model sizes, accuracy, number of parameters, and neural network depth. As part of this video, we are using the exception, VGG16, and ResNet 50 models. Let's get into our notebook. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I am using here are also available in the description. In the notebook, I reference some articles and GitHub sites that I found useful for understanding and for some code snippets. You may want to take a look at those after you get the notebook. I'll be classifying an image of a car, and later I'll use part of an existing model to create a new classification model. My first step is to get the data I'll need. Here's the picture I'll be classifying. Our first try is to use the ResNet 50 model to classify our car image. The 50 in the name is supposed to stand for the number of layers in the model, but we see here that when we retrieve the number of layers, we have a depth of 176. There are over 135,000 weights used in these 176 layers. The model is made to predict 1,000 different classes. We can see here that the top prediction is for a minivan, but the confidence level is only at 23.8%. We can try the same thing with the exception model. In this case, we see that the model has a depth of 134 and includes over 112,000 weights. It's interesting to see that the exception model returns the same top 3 predictions. The difference is in the confidence, where exception gives us a 43.6% confidence on minivan, where ResNet 50 gave us 23.8%. Still, both models are wrong. Let's look at the VGG16 neural network. If we instantiate the model, we see that the model has 23 layers with over 46,000 weights. As for the other models, it covers 1,000 classes. We could classify our car image just like we did with the 2 previous models, but instead we'll use part of the model to help in the creation of a new one. With the statement VGG16_model equals VGG16, weights equal ImageNet, include_top equals false, we tell the system to instantiate the VGG model without the last few layers that take care of the classification. We end up with a model that has 19 layers instead of the original 23. What those layers do is process the images into a set of components. We can use these already trained layers to do the same thing for our model. This way, we don't need to provide as many images for the training, and the overall training will be much quicker. We prepare all our images from our training, testing, and validation set, and use the resulting images to train, test, and validate our model. We end up with pre-processed images classified in the 3 categories of our original sets. As we can see, the categories were transformed into numbers with 0 for BMW M3 Coupe, 1 for Elantra, and 2 for Volvo X90. We also see that the same conversion was done for each set, so we are consistent throughout. After flattening our images, we're ready to train our new model that contains 3 layers. The model that fit method shows that we are going for 25 iterations, and we pass the training and validation data. Since we capture the history of the training, we can plot the accuracy and loss. Now that our model is created, we can try to classify an image. We see that the result is that the image is classified as Electra with 100% confidence. Note that I chose to show the processing of images in 2 separate steps, one for the pre-processing of the images and another for the classification. We could have put the 2 steps together and indicate that the layers coming from the VGG16 should not be retrained. It would make more sense to do it that way. We saw that we can take advantage of existing models to advance our projects. Neural networks allow us to reuse existing models to create new ones, as we saw in the VGG16 used for car classification. This can be a great help in getting to a solution. See you next time on Bite-Sized Data Science, and don't forget to subscribe.